of similar to what you guys have here. On this screen, I've asked you guys to place an arrow, or what I was just doing on the previous screen, how you can draw a line, that would be fine too. What's going to happen is, and I say that this is how you're going to see them, I'll actually show you how you guys are going to see them a little bit differently, because you guys are going to see them already drawn. It's hard on a computer to actually draw an arrow or a line, as I would here if I said to place an arrow to mark 18 milliliters, where here this is the 35 milliliter syringes, or a syringe, not syringes. So they're marked off in ones, so where this would be one, right, oh, I don't have a pen here, where this would be 1, 2, 3, 4, oh, no, sorry, that's 0, that's nothing. Then it would be 1, 2, 3, 4, and that's why this can be 5. Then it's 6, 7, 8, 9, and that's why this is 10. So going all the way to 18, I would see that, it's between the 15 and the 20 here, so I'll count 16, 17, here's the 18, sorry, that's terrible. So that's what I usually do on a paper quiz, is I just ask people to, draw a line as to where that would be. But what you guys are going to see is there's actually going to be a stopper already in the syringe. Right now we're going to look at this for practice, and I'll show you exactly how that will be listed. But I want to show you the difference in some of these syringes here. So what you're seeing down here, the second syringe, this is a 12 milliliter syringe, and you can see those dashes, those longer lines are already counted off in ones for us. So there's our 1, our 2, our 3, our 4. Well, there's 4 lines in between. So this particular type of syringe, when you see your whole numbers counted off for you and there's 4 lines in between, we're going to count in decimals here. So think evenly. I wouldn't count between 1 and 2, for instance. So here's 1 and here's 2. Between 1 and 2, I wouldn't call this 1.1, 1.2, 1.3, 1.4. That's because this would have to then be 1.5. And it's not. It's 2. So therefore, we're going to count this off in 2s, in decimal, I'm sorry, I should say 2/10. We're going to count it off in, 0.2 is what we'll end up doing. So the first line behind the 1 is actually 1.2. So that's 1.2. The second line behind the 1 would then be 1.4. So there's the second line back there. The next one would be 1.6, this one would be 1.8, and that's why then therefore this is now 2. And we'd count in between all the other numbers the same way. So for instance, here's the 6. The first line after the, oh, I didn't mean to move my, my picture there. I always do that when I have these pictures on here. So the first line behind the 6 would be 6.2, and then 6.4, 6.6, 6.8, and then 7, and so on and so forth. A little bit different just looking at this one, how it's those were counted off in whole numbers, but there was only 4 lines between the 2 whole numbers. So therefore that we had to count it off in 0.2s. So all right, guys, in this chapter we want to take a look at, we're looking at a couple different things. We want to look at labels and syringes, and then I'll have a short video to add to this to also take a look at our medical abbreviations and some of the ones that I want you to be familiar with. So in this video, we're just going to look at syringes and medication labels, as that is going to be very important as we get into our dosage calculations in the next couple weeks. So we want to know how to read the different increments on the sides of the syringes. Looking at the screen that you guys have here, you guys can see there's a couple different types of syringes. You can see that there is a dropper in there, or not a dropper, but a stopper that will allow you to draw the medication. Obviously, there's no needles on this example picture, but you take it and you put it into a vial, and then you can draw the medication into the syringe to the certain point, depending on how much medication is needed. So most of the time syringes are labeled in either milliliters, or sometimes you might see cc's, and cc's is the same thing as milliliters. It's just a different way to list that. But you can see there's lots of different size syringes based on what is needed. In this example, we can see, like I said, a small syringe there at the front. This first syringe is only a 1 milliliter or 1 cc syringe. Meaning if I only needed to give a patient 0.4 milliliters of medication, I would more than likely use this syringe because I'd be able to draw it to the 0.4 spot. Whereas instead of using the 10 milliliter syringe over here, that's measured, that goes all the way to 10 full milliliters, if I only need to give part of a complete milliliter, 0.4 would be somewhere way up here. So it wouldn't make any sense to use a 10 milliliter syringe. I would use a 10 milliliter syringe when I needed to give a lot more. So maybe 8, 7, or, 9.5 milliliters. 9.5 9.5 milliliters would be the halfway between 9 and 10. So that's what we would use, the 10 milliliter syringe for. So the way that you guys are going to see these listed, for instance, if you guys see, so we've already seen, this 1 milliliter syringe. I'll show you guys that in just a second, a better picture of that. But what you're looking at in this second syringe right here, this is only a 2.5 milliliter syringe. This is common with our 3 milliliter syringes as well. But you'll notice that, in comparing, say, if I'm looking at the comparison between our 2 milliliter syringes right here, I'm looking at the difference between those two. Look how on that first one, the longer lines, so those longer dashes right here, are counted off in halves. So if I have 0.5 and then 1 and then 1.5 and then 2, look at the distance between 1 and 2 on this syringe. Here's 1 to 2. Whereas look at the difference between 1 and 2 on this syringe. This one, the second one right here, or I should say the third one on your screen, is actually very similar. On that second one, on the third one on your screen here, between 1 and 2, once again we're seeing 1.2, 1.4, 1.6, 1.8, and that's why this is therefore 2. We'll see the same thing between the 2 and the 3. This would be 2.2, 2.4, 2.6, 2.8. That's why this is 3. And we could keep going, so on and so forth. I can't do that on this syringe, on that second one on your screen, because if we did that, say I'm starting here at the 1, if I said 1.2, 0.4, 0.6, 0.8, this would have to be 2, but instead it's 1.5. So in the case where we have, where our longer increments are counted off for us in halves, in this case, we're actually going to count off in I should say tenths, but in 1/10, a little bit different than we did on that, the third one on your screen there. So going, starting at the 1, this is actually going to be the first one right after is going to be 1.1, 1.2, 1.3, 1.4. That's why this is 1.5. And then we can just continue to count forward. 1.6, 1.7, 1.8, 1.9. Therefore, this is 2. And we'll count the same way after the 2. 2.1, 2.2, 2.3, 2.4, and there's 2.5 already counted off for us there. So that's the big thing I see on these syringes, is knowing the difference between those two types of syringes. So the biggest way to see that difference, and let me get some of these markings off of here so it's not so crazy looking. The biggest thing to be able to tell the difference between those two is, again, look at the distance between your whole numbers. The distance between 1 and 2 on this syringe, there's 9 dashes in between 1 and 2, counting the 1.5 that's already marked off for us. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the one that we count off as 0.1. Sorry, that's a horrible looking one. 0.1, 0.2, 0.3, 0.4. We count in order between our whole numbers. Whereas the other one, looking at now this syringe, again, since it's a lot closer together, everything has to be evenly spaced. I couldn't count that as 0.1, 0.2, 0.3, 0.4 because, again, this next line that's counted off for us would have to be 1.5, and it's not. So, therefore, we count off in 2s instead. So, in this case, again, that's where we count off 1.2, 0.4, 0.6, 0.8. And then between like the 3 and the 4, this will be 3.2, 0.4, 0.6, 0.8, and so on and so forth. The ones like this one are a little bit easier because they're counted off in whole numbers, so obviously the lines in between would be halves. So it would be, 4, 4.5, 5, 5.5, 6, and so on and so forth. So those are a little bit easier. Like I said, the biggest one, I think, is knowing the difference between these two. Your 1 milliliter syringe, let me see, milliliter syringe we were looking at on the previous screen, this one, except this one was whole numbers compared to our picture of one like that. Yeah, this one right here. So this gives you a clearer view of that 1 milliliter syringe. You can see it goes all the way to just 1 full milliliter, so it's listed there as 1.1, not to be confused with 10. When the decimal's there between the 1 and the 0, we know that that's 1. So you'll notice that all the lines before that, those larger lines that are counted off for us, are 0.1, 0.2. So these are already counted off in tenths for us. That means those lines in between are actually our hundredths. So, this one's actually going to be very similar to that 2-point decimals that we're seeing here. But you notice that here's 0.1, here's 0.2. If you were to count, let me see if I can zoom in a little bit closer there. If you could count, there are 9 lines in between. So there's 4, 5, 6, 7, 8, 9. There's 9 dashes in between the 0.1 and the 0.2. So what that means is, here would be 0.1. If I needed you to administer 1.11, that would be that first line right behind the 0.1. The next one would be 0.12, 0.13, 0.14, and so on. Obviously, halfway would then be 0.15, because it's instead of 1.5. Again, these are already small. These are small, so it's like we've moved the decimal just to the front instead. So look at it. It's a way to kind of look at it very similar to our other syringe. So what's going to happen here, if you think about it, needing to administer 0.34. In this case, that means we'll go to the 0.3, and you just simply count 4 lines behind it. Oh, sorry, terrible mark there. That would be 0.34. Like I said, you'll already have it counted off for you, and your answer on your test will have to be to then tell me how much medication is in that syringe. So it makes it a little bit easier. Oops, I meant to move that, not to draw a line there. Okay. So if if in the case where we needed to administer 0.68, very similar, I would go to the 0.6, and then I would count 8 lines behind it. Let me zoom in on this a little bit. 8 lines behind it. Here's the 5, 6, 7, 8. So that would be right here. Okay. So I hope that helps with that 1 milliliter syringe. And then here you're seeing, again, another 1 milliliter syringe. I don't know why I have 2 of those on there. I didn't mean to do that. And then here you can see another 3 milliliter syringe where, again, look at the distance between 1 and 2. We're seeing 9 lines in between. So here you'll see if I said to administer 2.3 milliliters, we'd go to the 2, and then 3 lines behind it would be right there. Again, you're going to see on your examples that the stopper will already be there for you. You just have to tell me how much medication is in that syringe. Okay, so let me show you how these will be listed on URLs. So as you can see on the screen here, number 1 and number 2 both have a stopper and an arrow on the screen for you. So that's how you guys will see it on URLs quizzes, as that's kind of the easier way to do it on a computer. Again, like I said, it's harder to draw a line on a computer, so this is going to be easier. So on number 1, I will ask you how many milliliters has the nurse drawn into the syringe there, or the medical assistant, again, whatever, has the person drawn into this syringe. And so you can see, what we're looking at is a 3 milliliter syringe. So keep in mind what we talked about, the distance between 1 and 2. So there's 9 markings in between. So these are the ones we count off in 1. So 0.1, 0.2 in between, and so on and so forth. So what that means is, between 1 and 2, or so 1 and 1.5, those four markings in between, that's your 1.1, 0.2, 0.3, 0.4. That's why this is 1.5. So what we're showing on number 1, it looks like the stopper is to the second line past the 2, and the arrows there clarifying that for us. So since the first line behind the 2 is 2.1, the second line would be 2.2. So the answer to this would be 2.2 milliliters. On number 2, we're looking at a 1 milliliter syringe. So very, very similar to the image just above it where we saw, 1 to 2. Very similar, it's just the distance between 0.1 to 0.2 instead. It's like, again, we've moved the decimal to the front of the number, but it's still 9 markings in between. So, we're counting it off very similarly, except instead of just, 1.1 and 1.2 like we had on the first one, this is just going to be 0.11, 0.12, 0.13, and so on and so forth there, between the 0.1 and the 0.2. It looks like number 2 has, let me get all that off the screen for us. It looks like number 2, and I'm going to zoom in just to show you guys, and you guys will be able to see this pretty clearly here, and you'll be able to see it pretty clearly on your quiz too. But it looks like we're halfway between the 0.3 and the 0.4. A way to think about that, halfway between 3 and 4 would be 3.5, right? So imagine we've just taken that decimal, and again, we've moved it to the front of these numbers, so it's actually 0.3 and 0.4. So therefore, we would do the same thing at the halfway, so this would just be 0.35, or 0.35 would be correct as well, because we're right there at the halfway point. Okay. So very similar to some that we've seen before. Oops, I didn't mean to take that all the way down there. Okay, so that's what we have on number 1 and 2. Looking at number 3 and 4, very similar. Number 3 looks like we're right at the 0.5, so that one's pretty easy to see in that 1 milliliter syringe. But just to show an example, if I were, say at the, let's say the third line behind the 0.8. So let's say I'm at the third line. Sorry, I'm trying to draw it as close as possible. That is horrible, but you guys see what I mean, that I'm at the third line behind the 0.8. So if this is 0.8, remember the first line is 0.81. The second line is 0.82. So the third line would be 0.83. So if it's 3 lines behind the 0.8, keep that in mind there. So I wanted to show you that in case we have something that's not right at one of those marked off points. And then lastly there, number 4, we're looking at a 10 milliliter syringe. The 10 milliliter syringe, again, pay attention to the distance between 1 and 2. We only have 4 lines in between, so therefore these are the ones we count off in 2/10. So 0.2, 0.4, 0.6, and 0.8 in between all of our numbers. So between 1 and 2, it's 1.4, 1.2, 1.4, 1.6, 1.8. If I was talking about, between, let's say if we were talking about the distance between 3 and 4, then those lines would be 3.2, 3.4, 3.6, and 3.8. But it looks like in our picture there, we're obviously behind the 5, and we're not quite to the 6. Hard to really kind of see it on this one, but I'm counting 1, 2, 3. It looks like we must be at the 4th line past the 5. So the 4th line past the 5 is the one that's right in front of the 6. So remember, we count that off as 5.2, 5.4, 5.6. Therefore, that 4th line is going to be 5.8 on our screen there. So that's how you guys will see those syringes on your all's quizzes. They're already marked off for us, but the biggest thing I wanted to show you guys in this lecture is just knowing the difference between those different size syringes and how we count off those different increments. So I hope that helps. The next day's lecture, I want to take a look at medication labels. We've all seen medication labels before, whether it's something we buy over the counter, like Advil, or the generic brand ibuprofen, or perhaps maybe even something we have a prescription for. We've seen lots of different medications. Those medications have all kinds of different things written on the labels, and I want to talk to you guys a little bit today on how to read those different things. What's going to happen next week is so here's a list of some of the things that you guys will see on a label. So at the very top there, it says the generic name. So the 2 different things we're looking at right here, generic and trade. Those are the names of our medications. The trade name, more a synonym, and one that we maybe commonly see this as, is brand. The trade name is the same thing as the brand name. If you buy the brand name drug, typically it's the medication. It's a little bit more expensive, but the brand name is really easy to spot on a label because you'll see a registered or a trademark symbol, as it mentions right there. Typically the more common one, that R with a circle around it, is what that first symbol is actually showing, hard to read. But that just simply means that it's registered. So Advil, for instance, is the brand name medication. So behind the L in Advil, you will see that little symbol, and that is a way to know that that is the trade name of that medication. Whereas the generic name, typically, a generic name is typically the cheaper medication, the cheaper version. It's the non-proprietary name. As it mentions there, it includes any drug marketed under its chemical name without any advertising. So on any medication, the generic name has to be on a label. The trade name does not. If you're buying the trade name medication, somewhere on there will also be the generic name. If you're only, however, buying the generic drug, the trade name does not have to be on there. Although sometimes people might put the trade name on there for the purpose of trying to sell their product. Like ibuprofen might say comparable to Advil, so you know what you're buying. But by law, it does not have to be on there. The generic name, however, does. But that's the difference between those two. The third thing you guys are looking at there, the manufacturer. This is the name of the company that manufactures the drug, that produces and makes that drug. So you've probably heard of a lot of common manufacturers of medications like Pfizer, Eli Lilly. We're going to see some different examples, and some of them might be made up in the examples that we'll look at, but oftentimes it's real easy to spot the manufacturer because their logo is on the label, or sometimes it might even say manufactured for, and then it gives the name of the company. We'll look at some examples here in just a second. And then the National Drug Code number, the next thing you're looking at there. The National Drug Code number is kind of easy to spot because you'll see on there are those three letters that stand for that. National Drug Code, you would see the symbols NDC. And it's only those symbols you would see, NDC. So we make sure we're looking out for that. What the National Drug Code does is it identifies the manufacturer, so there's a certain number that represents the manufacturer, typically separated by dashes. We're seeing this, the manufacturer, then it's dash, the number for the medication, dash, and then the container size. So that's going to be pretty easy to spot because of the NDC symbol that's in the front of it. Lot number is placed on a medication prior to shipping to identify the lot that it was made in. A lot of times, a manufacturer will create a batch of medication and then give it a number before it ships out, and then on the next batch that they create, they'll give it a different lot number. This helps to identify, where that is, that particular medication is going, what pharmacies it's being sent to, but it's also really, really important for the purpose of recalls. If for any reason something goes wrong in the manufacturing process, say something accidentally slipped or spilled into, that batch, then the manufacturing company can get in touch with pharmacies and say that we need to recall lot number, blah, 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 whatever number, and then all pharmacies will be able to look for that number of that medication and be able to send it back to the manufacturer because it's not something that should be sold to a customer. What you guys will probably see on lot numbers, I probably won't ask for the lot number because on all the labels that we will see are for class purposes and are only example labels. And so you probably won't see an actual lot number on there. So I more than likely won't ask for that, but I'll show you on a couple of these where those lot numbers would be found. The drug form that you're seeing there, the drug form is exactly what that implies. It wants to know the name or the form of that medication. So what type is it? Is it a cream, a capsule, a caplet, a drop, a tablet, a suppository, a syrup? There's all kinds of different forms and ways that we take medications. And so oftentimes on the label you will see the form that medication is packaged in. Next, you guys will see the dosage strength. The dosage strength is the amount of medication that is in each dose of medicine. So it's the strength per dose, such as tablet, milliliter, syrup. On any tablet medication, it'll simply tell you, that there are so many. The most common way to list this would be in milligrams. As we've, talked about metrics already, the most common way that's listed would be in that metric dosage. Sometimes it's grams, sometimes it's micrograms. So that's really what to look out for are those metric units, milligrams, micrograms, grams. Those are your most common units that you guys will see as far as dosage is concerned. That's supposed to be connected there. My finger is not wanting to do that. But the most common one you'll see is milligrams. On any tablet medication, it'll just tell you there are so many milligrams. It'll be somewhere real big on that label, and that just means if, for instance, it's 50, that just means that there are 50 milligrams per every 1 tablet of medication. Whereas if it's a liquid medication, it has to tell us what's considered a single dose of liquid, because 1 milliliter could be a single dose, 2 milliliters, 5 milliliters. It needs to tell us that there are 50 milligrams per a certain amount of liquid. So you'll see per milliliter, or even per 2 milliliters, or per 10 milliliters, whatever. But that will tell the person who's taking this drug that there's 50 milligrams for that amount of liquid. So, depending on what you need, you may have to take more than just the 1 milliliter. So we'll get into that and some of those examples, but that'll help us with our dosage calculations next class. The next thing you're looking at there is the usual adult dose. This is simply just how a typical adult takes this medication. Oftentimes on medications that are, based on a prescription, a doctor will tell you what you need to do. We'll say to take 2 tablets with food once a day or something like that. But there are some medications that do not come with a prescription, so a patient needs to know how to typically take this. So somewhere on that package, if it's not right on the label, it will sometimes say see package insert or something of that nature, where it will tell somebody who's taking this how to take this. And so that's oftentimes pretty helpful. The total amount in the vial, packet, or box is exactly that. It just indicates the total number of items that are in the container. So if it's tablets, it'll say somewhere on there that there are 30 tablets in the bottle. There are 100 tablets in the bottle. It tells you exactly how much is in there. If it's a liquid, it'll tell you how many total milliliters are in there. So if it's a liquid medication, it may say there are 70 milliliters, and that's the total volume, so the amount of fluid that's in that container. And then lastly down there, the prescription warning. On a medication that is based on a prescription, there has to be a prescription warning on that label, meaning that medication is available only by prescription. So a pharmacy cannot just sell that, to anyone. The customer must have a prescription before that can be distributed. So you'll see somewhere on there, something that indicates this is available by prescription only. I can't just walk into Walgreens and just grab this. I have to have a doctor's prescription. Oftentimes this is written as RX only. So when you see that, that's exactly what that means. It just means prescription only. So, just looking at one like medication, a blank different questions. Where some of the things are already pointed out for us. If I asked you for the generic name of this drug, it is the morphine sulfate. Notice that the trade name was not asked for, and that is because this is the generic drug. Notice there is no registered symbol. Remember, that's what we're looking for when we're looking for a trade drug, a trade name or a brand name. And that's not anywhere on this label, so therefore morphine sulfate is the name of the drug, and it happens to be the generic drug. Down there at the bottom, you guys can see the manufacturer is just PL Pharmaceuticals. So you can see it's just the logo is put on there, their company logo. I would more than likely, if it's not on a label, I probably won't ask you for it. So I wouldn't ask for the national drug code number here. Notice that the person wrote not shown, and that is because it's not on there. And remember, the national drug code number is real easy to spot because we're going to look for NDC. Same thing with the lot number. It is not on there, so I probably wouldn't ask for it. The drug form, it does tell us that it is an injection, so you can see that on that label. So it tells us right there. The dosage strength, so see what I mean? Morphine sulfate is a liquid medicine, so you see that the dosage strength is listed as 10 milligrams / milliliter. That means that there are 10 milligrams of medication per every 1 milliliter of liquid. So that's going to tell you how much is in there. So that's the dosage strength. The usual adult dose, over here on the side, it does say for usual dosage, just see package insert. So that's what was written there, is how we would see package insert. The total amount in the vial or packet or box is again listed right underneath that dosage strength. You can see it is a 1 milliliter vial. If that's hard for you guys to see there, I circled it in green. It's a 1 milliliter vial, so that's the total amount in this medication here. Sorry, it's not working with me today. And then the prescription warning. It does tell us in the middle of that label we see RX only, and then the expiration date, again, I would not ask for that. It is not shown, so don't need to worry about that one. Or maybe here's some a different type of tablet heads label similar to this one. And then I'm going to ask you a few questions about it. So I want to show you guys what these different things are and how to be prepared. Okay, taking a look at the next label. So this is what you guys will see on a quiz. So it's just a label like this, and there will be a question listed underneath it. And then the next question will probably have the same label, and you just will get a different question based on that label. So if I asked you, what is the dosage strength for this medication? The dosage strength, you can see right there real big. Typically the dosage strength is really easy to spot. It's one of the bigger things that will be on the label. They've even listed it down the side here to show that for every tablet of this medicine you get 2.5 milligrams. Notice that there's no need to write 2.5 milligrams / tablet, that's per tablet. That is always understood on a tablet medication, so that is not listed that way. This is the generic name, so I would ask you the generic, and it is the generic again because you can see there's no registered or trademark symbol, so we're looking at the generic drug here. The drug form of this medication, it is a tablet, and that's always going to be listed on there for us. Let's see, the National Drug Code number. Don't forget, for the National Drug Code number, we're looking for the letters NDC, and there it is. So the National Drug Code number is that 54458999909. And that's how we would list that out. And your answer would be NDC and then the number. How many, or the total amount in the vial, packet, or box? If you can see down there at the very bottom, it does say contains one dosage card of 30 tablets. So it means that there's 30 tablets in there. In some cases, I might ask for, again, the prescription warning. You can see that real big on there, RX only. I might ask if there's any special storage instructions on this medication, and it looks like over here on the side there's a couple different, there's store at a certain temperature, protect from moisture, and you can list any of these in a tight container, something along those lines. The manufacturer is, you can see it actually says manufactured by Lupin Limited, so that's what that would be. Be careful, as this says packaged by and this says distributed by. So there's 3 companies involved in this process. The actual manufacturers who created that, so therefore it would be the Lupin Limited on this one. Okay. And then here's one we're also going to take a look at the other one. If I asked you guys, what is the brand name of this medication? Real big on this one, the Thorazine, because you can see again that registered symbol does tell me that this is a brand name drug. Whereas then the generic, like I said, the generic name always has to be on the label. And so that's what we're looking at right there, the chlorpromazine hydrochloric, because that's HCl. So that whole thing is the generic name, is how you would list that. If you put the word injection in there too, that's totally fine. I go in there and we'll override that if the computer doesn't mark you right. But that is the generic name. The form that medication comes in, that's where that injection comes in. It is an injection. So that is the form. The manufacturer for this medication is the SmithKline Beecham. That is right big and bold at the bottom. That's their company logo. But even over here to the side, you can see where it says manufactured by SmithKline Beecham Pharmaceuticals. The dosage strength, because Thorazine is a liquid medication, that injection, you are going to see the per milliliter, so 25 milligrams / or per milliliter. The National Drug Code number, you can see listed underneath that, the NDC 0007 506201 listed there. The total amount in the vial, packet, or box, it is a vial, and it looks like there are 10 milliliters in that vial. So just a couple of different things there. So that's what we're looking at on our medication labels. So it's more like the medications are kind of like a seek and find that I'm looking for. I'm going to give you a label, and then I'm going to ask you certain questions about that label, and you just have to fill that in. So you just have to look for it and see what that is and then fill that in. All right, guys, I hope that helps. If you guys have any questions at all, just let me know.